Sending proprietary data to a public cloud AI API risks that data being harvested for future model training. To prevent leaks, the system must be physically contained within a zero-trust, air-gapped local architecture. Privacy in a local system depends on modularity. By splitting the AI stack into distinct functional layers, you create checkpoints that can audit, filter, and restrict the flow of data before it ever reaches the core model. This stack consists of the presentation UI, the PrivateGPT API, the Llama Index Orchestrator, the Qdrant Vector Store, and the Ollama Inference Engine. This structural isolation lets you govern the data environment securely, keeping every byte within your physical perimeter. The ingestion process begins when a user uploads a sensitive document. The presentation and API layers receive the file and begin preparing it for the local database. The orchestrator parses the document into manageable chunks, while an embedding model converts that text into numerical vectors. Simply being offline doesn't make a system secure against internal threats. If you ingest sensitive payroll or HR records, you have to ensure that a regular employee can't query the system to uncover them. We solve this with context-based access control. During ingestion, the orchestrator attaches permission metadata directly to the individual document chunks. By gating the data at the vector level, the system ensures that classified context is physically isolated from any user who doesn't have the required clearance tags. When a user submits a query, the API layer receives the prompt and automatically appends the user's specific clearance tags to the request. The orchestrator searches the vector store, returning only authorized chunks. These facts combine with the query to form a super prompt. PrivateGPT then hands the finalized data to the inference layer via a local API call. Ollama maps the model weights to the GPU, processes only the pre-authorized context provided in the prompt, and generates a response to route back up the stack. Because the reasoning engine is isolated and only receives context that has already been filtered, it remains incapable of retrieving or revealing unauthorized information. Heavy local workloads often reveal a hardware bottleneck. If a single GPU manages both the embedding model and the LLM, it constantly swaps memory blocks. Shuttling these parameters across the PCIe bus creates severe latency, stalling the system during processing. Let's test your understanding of how the architecture handles this. Suppose a junior employee queries the system for a classified Q4 layoff strategy. Think through the blueprint. Which layer and which specific mechanism will stop this unauthorized request from being answered? The orchestration layer identifies the junior employee's clearance tags and queries the vector store. Because the tags don't match the metadata on the layoff documents, the vector store rejects the retrieval. No sensitive data ever reaches the model. To eliminate the model swapping bottleneck, you must decouple the hardware tasks. You can configure PrivateGPT to run the embedding process natively on the system CPU using Hugging Face. This frees the GPU to focus entirely on Ollama, resulting in smooth, high-speed inference during large ingestion tasks. This setup creates a stable production environment. PrivateGPT orchestrates the workflow, Qdrant serves as the permission-gated memory, and Ollama provides the isolated reasoning. Implementing this blueprint allows you to deploy a production-ready intelligence engine where your data stays on your disks, your inference stays on your GPUs, and the perimeter remains closed.